So the blue line would be the parent function, which would be 2 to the x power, and the red line is the equation that we had.
And then we have the table over here. The domain is negative infinity to infinity, and the range is -6 to infinity.
Is it a function? Yes, because it actually does pass the vertical line test.
It's increasing from negative infinity to, oh wait, no. This also messed up. It's increasing from -6 to infinity. Messed up. And it's not decreasing at all.
Transformations is it moves down 6 from the parent function, and the parent function is y equals 2 to the x power.
The x-intercept.
Oh, crap, sorry. Go back. Wait, dang it. Okay.
The x-intercept is 2.5 and the y-intercept is -5.
The number of turns and continuous, 1 turning point, and it is a continuous line, so it doesn't stop.
Is that it?
That's
Can you guys
the
go back to last the graph and talk about it for a minute? The turning points don't apply to things that are exponential, are not polynomials, it's exponential. So like x to the first we talked about, x squared, x to the third, those things are polynomials and those have degrees and terms that we talked about, there's one less than the degree. But exponential is not a polynomial, so you don't talk about terms and number of degrees. So let's go back to where Jason thought he made a mistake. He said
With the
increasing intervals, but go back to the graph and let's talk about it. Increasing intervals, he stated on the slide, negative infinity to infinity, right? That it was increasing. Was that correct, or did he make a mistake?
That was correct,
Why, Danny?
because even though it looks like it's not increasing, it is increasing.
How many of you have studied exponential functions in science? And what does exponential mean to you? What's exponential mean?
Danny.
It grows, so did you see Danny's hand? It went
Yeah.
straight up after